So what you need is you need to check. Let's check how these unless tokens actually needs. So unless tokens, that's what we need, and then we can see what are the arguments of these unless tokens. Split column into tokens using this tokenizer package. So they are using so that's what it needs. So you need the data and the output, input, and the tokens are in words, but basically what you can do is you can just use input, the text, the type of data that you want to tokenize, and the output would be the word. Yeah, so the output would be, I think they have example, that's the text, unless tokens, word, text, n-grams are like bigram, unigram, trigram, or something. If you want to connect multiple words, let's say in the first one, if you want to do, if we take this example, maybe the first one. So if we take this example, if you do unigram, that means only one word is considered as a token. Otherwise, if it is bigram, so you take this one, COVID is as one word, then the next one is a will be considered again as a new token. It goes like that, and again a new, so it will explode, you know, this will really increase the number of data variables that you will have. That's why text will make your data very fat, at least horizontally. So this when you do the bigram, so this will be as one, you know, COVID, maybe if I separate them with a comma, so one variable, the next one here. So this is 1, 2, 3, 4, 5, 6, like 6-word sentence, but when you make it bigram, so it will be 1, 2, 3, 4, actually 5. Okay, COVID is a new viral and then viral disease. So if you also make it triple, then it will go like COVID is a. This will be one trigram, and the next one would be is a new. That will be the next trigram, and then a new viral will be again the next trigram, and then after that new viral disease. This will be the last trigram. That's how you do in n-grams. Then let's simply run this tidy COVID. Let me actually change this, tidy COVID, and it will take a little bit of time until it gives us the result. So that's probably I made some error. Object COVID data is not found. Okay, since I didn't run this, so once I have that, I can run like load my library, and then after that I can do the tokenization. So this will give the tokenization. So you see the tokenization is giving us this number of tokens. It's really large, so it's 79,786 observations and 4 variables, because it's reversing, you know, it's changing it. So it's putting it in yeah, so the tokens will be like this. Yeah, so they are already tokens. We already have tokens. The next thing is we need to decide whether to remove stop words. Stop words are like words like is a new the or something, all this, you know, that don't give any meaning, or that are not necessary to change the semantic or the meaning of the sentence. They don't really. It's just for grammatical structure they are important. Otherwise, they don't change the concept. So these words you can remove them. For that, what we need is we need to load or attach the data, and that's stop words. So we call that stop words, and then after that we can use anti-join to remove those stop words. So let me attach this stop words. So these are already stop words. We have all of this in English. All these stop words, we are like 1139 stop words that don't really that are not really important in meaning, in changing the structure, unless you are doing like grammar analysis or something. Then if you are doing grammar analysis, then these stop words are important. Otherwise, if you are doing text analysis like COVID or sentiment analysis, then this stop words may not be relevant. So you need to remove these irrelevant words. To do that, what you need is let me call again my tidy COVID data, then tidy COVID, then I pipe it. Actually, yeah, then I can then I can simply call my tidy COVID, pipe it, and then anti-join. I can use this anti-join function, then stop words, my stop words. Then every stop word will be removed. Stop words. This will take a little bit of time, and then it will complete it. So I will join them. So if you remember, this was like 79,000. Now it's down to 45,000. So all those irrelevant words, this 1,319 words, that 1,139 English stop words that were actually in our data, they are all removed. If you want, you can also remove other custom stop words. Custom stop words, like if you really want to remove numbers or whatever kind of, let's say, because this is literature, so you can actually create custom stop words. Custom stop words. These are custom stop words. Will be, you can use in-row function or C actually table. And then from there you can create my word, that's our word list, and that could be, we take concatenated form of it, and then from there it could be like, I don't know, background, because this is abstract, usually it's written background, introduction, and then maybe methods, because they are the most common words, results, and maybe conclusion, because that's what they are writing usually when you write your abstract. Now, and then once you do this, we may do stop words actually, or we can actually combine them. What you can do is like custom stop words. Actually, we don't need this. We can simply use C, and then let's see if this works. Otherwise, we'll think about it for next time. So you can use C, custom stop words, and then maybe we can concatenate our stop words, update stop words, update, because, and then we can add this custom stop words with tidy COVID. So maybe If it is a different data structure, then we will have a problem. Otherwise, it should not be a problem. So stop words, and then our custom stop words. Yeah, so we have a problem. Oh, okay. This was with hyphenated word. Maybe, yeah, well, it's working. So then what you can do is you can replace that this stop words with stop words update, because it contains the English stop words and then the custom stop words that we just created here. So you can just simply use this instead of the 1139 stop words. Then we can remove all these the custom words that we just added. So this should be less than that now, because these words would be not much less actually, only 4 words are removed. Yep, theoretically at least. Yeah, so we have a problem probably because it's yeah, because they are in different shapes, I would say. Yeah, so I mean we can do bin rows. We can do bin rows, and then we can use a table. But I don't really want to do that now, at least at the moment. And then let's simply go back to our stop words. But that's how you create the custom stop words, and then you can use the table. And yeah, I think it's in the book, in the tidytext package book. They have a nice book. They have a really a good description of the stopwatch. The next thing is we do some quick plotting. Maybe we can do like a very quick plotting. Let's call this maybe tidy COVID data. What was our tidy COVID actually? That's our tidy COVID, and let's type it. And then let's count. You can count the words that we just created somewhere up here. This one is output, so you can count your words. You can count the word, and then once you count these words, you can sort it actually. So then you can put it in a bar chart or something. So we can sort it. And then once we sort it, we can also filter. Like we can filter, we can take only the top, I don't know, 50 or 100 or 10 or something. If you want to create, if you want to know only the top, I don't know, 50 most common words in the text, the data that we have. And then maybe we can do some reordering. So this is from ggplot2, you can mute it, and then word, because we just want to reorder it, because we want to reorder the word by its number, by how many times it appears. So this is exactly the same how you reorder your bar chart in ggplot2. So for that you can do reorder by reorder what we want to reorder word by what, by its frequency. That's n, because we are counting it, and we have counted it. So for that we will reorder. That's descending order actually. Like in the bar graph, it will be arranged from top to down. Like the bigger number of papers will appear on the top, and the bigger number of the words which with more frequency will appear on the top, and the words with have less frequency will appear at the very bottom, or at the 50s rank, because we are only selecting the top 50 words. Then you can still type it and continue with your ggplot2. So the next thing is just calling. So until now this is all about our data. So the next thing will be ggplot. So for ggplot, what you need is you can so we have defined our data. The next thing is aesthetic mapping. So the aesthetic mapping for the x function, we have a word, and then for the y, what we need is the frequency, how many times the word appears in our total text. Then we define our geom col, that's our geom column for bar graph, and then we can also do the field. We can color it. Let's see, we can make it like dark blue, or dark green, or whatever, I don't know. Then once you have that, you can reverse the bar graph, and that's simple. You can do. It's chord flip. That's chord. I made a mistake. Chord. No. Chord flip. I think that's it. No. Okay. It's because I haven't loaded my package ggplot. I haven't loaded the package, so then it will not detect chord flip. So once I loaded this should be easily. This function, the studio should detect this chord flip. Yeah, now I have it. So now I can run this and see my output in bar graph. So it will take a little bit of time until it counts all the words and then list only the terms that are that appear most frequently. So this is already done. We can have a look. So the really this is a bit dense. Maybe we can actually take only 10. And let's see. Oh, but still we have a problem. Okay. Actually, maybe we can. No, actually, this one is actually not the top 10, but rather the words that appear more than 10 times. So maybe if we increase this number, we can remove the words that happened not many times. So you can see in this plot, you can see that we don't have many words. At least here, we don't have many words. We have only words that happen 500 times, and then there are 250, and this one should be until 10. So maybe if we create until 100, then we can really shorten this graph and make it nicer, because we only want words that appear more than 100 times. So instead of like top, we can also do like top n actually. You can do like top n, yeah, something like that, and create your yeah. And so now we have our paragraph. So these are really the most common words that we have in our text analysis. So the first one is COVID, of course. It's that's the center of the main subject, and then 19 is because it's related with COVID-19. But you can also remove all these numbers and make real sense out of it. So these are the most common words, but we can also do some more analysis like COVID-19, like WordCloud or something, some kind of WordCloud analysis. So for that, what you need is you need WordCloud package, WordCloud, and then we can do color brewer. Maybe we can define our color choices, and for that maybe we can use this brewer pal. If I don't forget it very well, if I don't remember, if I remember it, and we can see 8 levels, and then we can start from dark to, then we can see our data. Maybe we can call it that's our data. This is our data. Then we can pipe it. We can pipe it with count. We can count the words, and then what we can do is we can do like with function, and then WordCloud. This is coming from WordCloud. WordCloud. Once you have WordCloud, you can use word function, and I mean the word, that's what it counted, and then you can define your maximum words. Let's say my maximum words should be I don't know, maybe 350, and then we can define the colors. The colors should be equals the pal that we just defined above. Yeah. So let's call our WordCloud package, and then once we define our WordCloud, once we loaded our package, we give the color brewer. Let me run this, and then we chose to present WordCloud of words that appear more than not more than 350, actually 300 words. Maybe it makes sense to do only 300 words or 200 words, because 350 would be a bit overloaded with words. Maybe 200 or 100 could also be. So we are going to plot all these words actually, which we have seen in the paragraph. So they will appear in WordCloud, and these words will be fat if they are most frequent, or they will be written in a very tiny text. So the size of the font would be will be related with the frequency or the number of times the word appears in our text. So let's see. Figure too large. Okay. Maybe we define only 100. Hopefully this works. Figure margin too large. Okay. I don't know this new error. Maybe let me work with this error. I think that's the first thing to do. Okay. Figure margin too large. Maybe I should do. So someone is working on this. Someone has already asked this question in not really this one. Okay, I guess we have I know what is this is what we need. Sorry. Yeah, so let me run this again. Then we have more margin. Now it should show. Yeah, it's writing all the terms that we need, so it's displaying all the terms until it's finished. It keeps popping up and new terms are being added in. Sholala. Yeah, anyway, these are the words that are being added. So you see new words are being added because we are only labeling the maximum number of words is 100. I mean, if you want, you can also plot 200, 300, probably 500 is okay. 500 most common words. Actually, the words that appear more than 500 times. No, 500, the maximum, the total number of words. It's not about the frequency, it's about the total number of words that you can put in this figure. And this, then the text size, let's say this curve is the largest, and that's why, because this word appears multiple times. If you remember, we also have seen it in the bar graphs. That's why this word appears more bigger in bigger fonts than some of the other words. Like coronavirus, this is also, it appears big because it's more frequent than the other words. Yep, that's how you do WordCloud in using tidytext, then using WordCloud package. Yeah, I think that's enough for today. If you are interested, we will continue to the next section in my next tutorial. My next tutorial will be more about more in-depth analysis of text analysis. Then we will proceed to classification or text classification using R. And we will have many interesting sessions coming up. And thank you for watching this video. And I would be very happy if you like the video or subscribe or share it to whoever is interested in text mining. Having said this, I wish you a good day. Thank you.